Okay, so before we move on to the next section, so we'll do a quick review of section 1, electrical charge. So in section 1, we talk about the two kinds of charges. So same type of charge going to attract each other. Repel each other. Same charge going to repel each other, and unlikely charge going to attract each other. Right? And the charge unit of charge is coulomb. So the charge of electron or proton is a very small number. It's about only 10 to the negative 19th coulomb. So we also talk about this. Can skip this millican. You can probably review the section 1 video more about the millican experiment to figure out the charge of electron. So there's two kinds of material, conductor and insulator. So for conductor, you can charge it by induction. So basically, you can use move a charged object closer to a conductor. So basically, you create a separation of charge. Then if you ground the conductor, negative charge going to move away. So if you remove the ground and remove this charged object, so the end result you charge the conductor. So for insulator, it's a different insulator. You can only polarize charge, but you cannot charge it. The different. So at the end, the insulator still have a neutral charge, overall charge, but you can only create a separation, partial separation of charge. It's called polarization. It's not really charged. Still, overall charge is still zero. You only create a separation of charge. So this is called polarization. This is the difference between induction and polarization. Induction really charge a conductor, but polarization is net charge is still zero. You only create a partial separation of charges. Right, this is all about section 1. We talked about last week. We move on to the section 2, electric force. So in section 2, we'll talk about how to figure out the magnitude of electric force mathematically. We'll use the Coulomb's law. So what's the difference between the electric force and the gravitational force? And this is another principle called the superposition principle. Basically, if you have multiple charges, how to figure out the overall electric force on a specific charge. Right, so what's Coulomb law? Coulomb law is basically gives mathematical description of how to figure out the strength of electric force. So electric force equals to it's a Coulomb's constant. This one is a constant, so you don't need to worry about it. It's always given. And the charge 1, charge 2, and this is a distance square. So inversely proportional to the square of distance. Basically, double the distance, basically you quadruple the 1 over the quadruple of the distance. Basically, you double the distance, electric force becomes a quarter of force. So this So that's the square of distance, inversely proportional. So remember it. So in this Coulomb's law equation, it won't give you the force is attractive or repulsive. You need to use the principle we talked about in section 1 to figure out if the same kind of charge going to repel each other, the unlikely charge going to attract each other. So the direction of the force, you need to figure out use the type of charge. Because this equation only use it to figure out the magnitude, but not the direction. Remember, we talked about forces. I forgot which chapter. The force, you have two is a vector. You have two components. One is the magnitude, basically the number. The other is the direction. So which direction? So what's the direction? So you need to figure out both. So this equation only give you can figure out the magnitude. The direction you need to use what we talk about section 1 to figure out. So remember when we talk about the vector calculation, we talk about the resultant vector. Basically, you have two vectors. How you can figure out the resultant vector based overall this to something like that. I just show you this illustration, not exactly. So this is the resultant vector. So this same thing, if you have multiple charges, like the one, you have one charge, two charge, another one charge. If you want to figure out the electric force on this charge, basically the two charges are going to have a force on this one. Sorry. So it should be this direction. It's attractive. This one, charge 1, charge 2, charge 3. So basically, charge 3 is a negative charge with two electric force active on it. So how the resultant force is what we talked about in the previous chapter to figure out the overall electric force on charge 3. So this is the principle of superposition, basically. So when we talk about an object is in equilibrium, so the net force is 0. So this is not an equilibrium. Something like that probably is in equilibrium. So the middle charge, we assume is charge 3. Have a overall charge. If you calculate overall charge, overall force, net force is 0. Net force is 0. So we can say this object is in equilibrium.
Like any other vector quantity, electric forces have both magnitude and direction. Consider a positive charge Q3 in the vicinity of a positive charge Q1 and a negative charge Q2. Suppose you want to find the net force acting on Q3. First, identify the individual forces acting on Q3. Because Q3 and Q1 are both positive charges, they repel each other. The direction of this force lies on the same line that joins Q1 and Q3. Q3 and Q2 have opposite charges, so they attract each other. The direction of this force lies on the same line that joins Q1 and Q3. The resultant force on Q3 is the vector sum of these two forces. The superposition principle allows you to calculate the electric force of several charges acting on the charge Q1 as the vector sum of forces of each of the charges acting on Q1 independently.
Right. So this is the so-called superposition principle. So this is the resultant force. overall electric force on Q3. So basically, you can use graphically solve it. Remember, we talked about so force 1 from tail to head. Another one is the tail to head. So overall is the tail of first force to the head of second force. So this is the resultant of electric forces. Right, so we can have an example. So here I have 3 charges. I have 3 charge particles. Right, so it have magnitude. We know the magnitude of all 3 charges. Right, so this negative sign means negative charge, and we know the distance between any 2 charges, so we can figure out the overall charge on Q3. So we need to figure out this one. Right, so what we know here, so Q1, Q2, and Q3, and the angle is theta equals to 37 degrees, and the distance between any 2 charges. So we need to figure out this 3. So first thing we need to figure out individual charges. The charge F31, F32. Then we use the principle we talked about in the earlier chapter. Just figure out the X component, Y component, XY component for each 2 forces. Then use the Pythagorean theorem to figure out 3, and angle. Use a tangent function to figure out the direction. Right. So the first thing we need to figure out is a repulsive or attractive, because if you forgot this part, you can mess up everything. So for this case, I have 2 forces. If you put this the direction wrong, if you put this one here, not this way, so you see the overall force is going to be different. So the first thing you figure out is repulsive or attractive. Basically figure out the charge is same kind of charge or different kind of charge. Right? Then you can calculate the forces. So in this case, you just plug in this here. This is the Coulomb constant. Put it in the charge. So in this equation, you don't need to put a sign there. Charge. Just put the absolute value of the charge. In the sign, you're going to use it's the same kind of charge of the charge to figure out the sign of the force. Just use the absolute value to calculate the electric force first. Then you resolve both force into X and Y component. You use the cosine and sine function. So in this case, cosine 33, sine 33. So because the 3,2 is on, so this depends on the definition or coordinate. So in this case, I think you use this coordinate. Because this force 3,2 is this direction, so it's on x direction, so its y component is 0. It's a 3, 2. Right? So the other one you need to resolve to xy component, so 3, 1. You need to resolve to xy, and the 3, 2 only has a x component, the y component is 0. Okay, then you can add up the x component total, add up both x component from both forces. So y component, add up total, you figure out the x total component, y total component, these two. Then you can use this to use a tangent function to figure out the direction. First thing, you use a Pythagorean theorem to figure out the total force on 3. Pythagorean theorem. Then you use tangent function. This is x total, y total, and you figure out this angle is a tangent function. Tangent function is opposite divided by adjacent. Right? Then you use inverse the tangent function to figure out the angle, 65 degrees in this case. Right. So Coulomb force, like we talked about, you have two charge, right? So two charge is a repulsive force, but however, these two charges are not in contact. So Coulomb force is a field force, it's not a contact force. So the field force is no physical contact. So it's through a kind of electric field. This force is electric field. So if we compare Coulomb force and gravitational force, why is no? Okay. So basically, both Coulomb force and gravitational force are field force. So gravitation, like you have an airplane flying in air, right? It's not in contact with Earth. However, it's still in a gravitational field. So both Coulomb force and gravitational force are both field forces. However, Coulomb force, like we have because we have two-handed charge, so Coulomb force could be a repulsive, could be attractive, depends on the charge, type of charge. However, gravitational force always attractive, right? Everything attracted to Earth, like, so it is always attractive, gravitational. However, Coulomb force, it could be repulsive, could be attractive. So this is the difference and the similarity, basically. Right, that's all for section 2.